about thermal and electrical properties of 3D printed material, and my subtopic is thermal and electrical properties of nylon. First, what is 3D printing? 3D printing or additive manufacturing is the process of making three-dimensional solid object from a digital file. First, let's watch a video about 3D printing technology.
3D printing technology is already changing the way we produce objects, from tools and toys to clothing and even body parts. 3D printing is part of a process known as additive manufacturing, where an object is created by adding material layer by layer. Additive manufacturing allows designers to create complex parts for machines, airplanes, and cars at a fraction of the cost and time of standard means like forging, molding, and sculpting. Now, smaller, consumer-friendly 3D printers are bringing additive manufacturing to homes and businesses. The first step of 3D printing is to create a blueprint of the object you want to print.
Next, thermal behavior of nylon with addition of multi-wall carbon nanotube. Carbon nanotube nylon 6 composite have recently been studied extensively to establish the effect of CNT failures and to achieve nylon materials with better electrical conductance and improve thermal and mechanical properties. Multi-wall carbon nanotube nylon 6 composite and neat nylon 6 synthesized subjected to high pressure high temperature treatment to investigate the effect of multi-wall CNT failure. A composite of 2.1 purified multi-wall CNT nylon 6 shows significantly higher melting temperature than neat nylon 6 with identical pressure treatment. The improved thermal stability is attributed to highly crystalline nylon 6 structure that reinforced by intercrystal bridge of multi-wall CNT. Thermal behavior of nylon with addition of graphene. Electric capability of nylon 6 can be enhanced when nylon 6 covers on the surface of flake graphite. The thermal stability of nylon 6 EG composite will enhance along with increasing mass percentage of exemplated graphite. Enhanced thermal conductivity of silicon carbonitride covered boron nitride nylon 6 composite. There is significant increase in thermal conductivity of the composite compared to the BN nylon 6 composite. The thermal conductivity of all composite increased with increasing particle concentration. Electrical behavior of nylon with addition of multi-wall CNT. Electrical conductivity increasing due to increasing the density of mobility of charge carriers as the multi-wall CNT weight percent increase. By using stretching method, the composite after fabrication improved and electrical conductivity exceeded a million times. Enhanced electrical conductivity of polypropyl coated short nylon fiber natural rubber composite. DC conductivities of natural rubber PPY composite is enhancing only at very high PPY loading and the maximum conductivity. The composite exhibits much higher AC conductivity compared to gum vulcanized. That's it. Thank you.
Good morning, everyone. I'm Phung Thamun and come from Arcane Craft Material Engineering. Today, I want to talk about the electrical and thermal properties of graphite. What is graphite? This consists of stack of parallel two-dimensional graphene shapes with sp2 hybridized carbon atoms which are tightly bonded in hexagonal rings, and pi orbital is distributed over the entire graphene sheet, making it electrically and thermally conductive. This is the diagram for the structure of graphite. There are various modifications of graphite and can be classified into graphene oxide, graphite intercalation compounds, and expanded or exfoliated graphite. Let us talk about the electrical properties. Doping of graphene strongly influence the electrical properties of graphene. The higher the concentration of p-type dopant, the more significant the rise in carrier concentration and reduction of sheet resistance. And also, the higher the concentration of p-type dopant, the more effective the doping process. Next, expanded graphite and high-density polyethylene nanocomposite. Electrical resistivity decreased along with increasing the accelerated particle size. A much lower percolation threshold due to a high aspect ratio of expanded graphite. Expanded graphite filler with higher aspect ratio is randomly well dispersed in the HDPE polymer matrix. Let's take a look at thermal properties of graphite. Polyethylene terephthalate and accelerated graphite nanocomposite. A thermal gravimetric analyzer is used to investigate the thermal stability of PET and EG nanocomposite under nitrogen or oxygen gas conditions. Thermal degradation at much lower temperatures and significant weight loss with temperature. Thermal degradation temperatures of PET and EG nanocomposites improved substantially with the addition of EG content, especially under the oxygen gas condition. Next, graphene nanosheet and aluminum nitride composite. As the number of atomic rings in the graphene nanosheet increased, the phonon dispersion changed and more phase space state became available for phonon scattering, thereby decreasing the thermal conductivity and negating the effects of phonon boundary on defect scattering. The thermal conductivity of the composite decreased with the addition of more graphene nanosheets. That's all for now. Thank you.
Okay, my name is Go Yong-wan, and I'm from Architecture Material Engineering. So today I will be discussing about the thermal and electrical properties of acrylonitrile butadiene styrene (ABS). Okay, ABS is actually made out of styrene, acrylonitrile, and 1,3-butadiene. Then the ABS combine the strength and the rigidity of acrylonitrile and styrene polymer with the toughness of polybutadiene rubber. Okay, so the next one I will be presenting about the thermal property. So actually, why is the thermal property so important? In fused deposition modeling, FDM 3D printing, linear expansion ratio of material is a critical factor in affecting the dimension of product. Neat ABS sample normally show warping after FDM 3D printing because ABS is said to possess high linear thermal expansion ratio. So when a relatively large ABS object is printed, this shrinkage will lead to delamination between the layer, which will lead to failure in printing. And okay, the different amount of organic monomorillonite OMMT is shown in the table 1. Denominated by ABS 1, which represent 1% of ABS pellet. Then the ABS 3% of 3 weightage percent of ABS pellet, and 5 weightage percent is the ABS 5. Okay, based on the table and figure, it can be seen that the linear thermal expansion ratio decreases with the increase in content of OMMT. So OMMT play as the hard segment which can restrict the movement of polymer chain, and also it can lower the linear shrinkage ratio. Therefore, the addition of OMMT in ABS matrix is said to be able to reduce the warping and deformation of 3D printed object. Therefore, the incorporation of OMMT to the ABS matrix have a significant improvement in terms of thermal property of ABS nanocomposite. Next, I will be discussing about electrical property. Pure ABS is still showing insulating behavior as expected. However, ABS can be modified into a conductor from an insulator by adding only a small amount of multi-wall carbon nanotube into the ABS matrix. The network formed by the carbon nanotube inside the ABS metric is said to be able to conduct electricity. Increasing concentration of CNTS inside the polymer does not have significant rate effect on electrical conduction because there is a saturation limit. And the electrical conductivity can be determined by applying the power relationship theory, which is known as the classical theory of percolation. A conduction network is formed in this multi-wall carbon nanotube ABS composite as the nanotube loading reach a conductivity threshold. From the graph, we can clearly see that the electrical conductivity of composite show a tremendous improvement as the weight percentage of carbon nanotube increases. Okay. In conclusion, the addition of OMMT is said to be able to reduce the linear thermal expansion ratio and reduce the warping and also the deformation of 3D printed object. Whereas the addition of multi-wall carbon nanotube is said to be able to decrease the electrical resistivity, increase the electrical conductivity, and also the observed EMI shielding value will increase. The observed EMI shielding value was higher than the limit required for a commercial application.
Assalamualaikum and good morning. My name is Hanija Binti Ghazali. I'm from Architectural Materials Engineering. Today I would like to present a topic about electrical and thermal properties of 3D printed materials, and I have been chosen electrical and thermal properties of polycarbonate as my subtopic. First of all, introduction of polycarbonate. Polycarbonate is one of the synthetic polymers. Polycarbonate is any of various of transparent thermoplastic characterized by high impact strength and high softening temperature. This is polyester made by the mixing of vinyl group, nickel group, and carbonate groups, and is formed by the reaction of bisphenol A BPA with carbonyl chloride through an interfacial process and forging process. Polycarbonate have a unique properties of performance characteristics such as excellent toughness, high heat capability, optical clarity, thermal stability, high transparency to the visible light. Thermal properties of polycarbonate. Firstly, transition point. The glass transition point of polycarbonate obtained from the inflection point of refractive index is 141 to 149 degrees Celsius. Secondly, melting point. The melting point of crystallized polycarbonate is about 230 to 260 degrees Celsius. Specific heat of the polycarbonate changes with time. Lastly, thermal diffusivity. The thermal diffusivity can be determined not only in the solid region but also at the temperature above the glass transition. Electrical properties of polycarbonate. The electrical conductivities of polycarbonate increase as the multi-wall carbon nanotube content also increase. The electrical properties of the polycarbonate strongly depend on the shape of the multi-wall carbon nanotube. The higher electrical conductivity of polymer is because of the better dispersion of multi-wall carbon nanotube. The electrical conductivity is strongly determined by the ratio of the figure. There are a few things that can lower the electrical resistivity, such as optimization of the basic conditions, the introduction of some processing additives, and the proper surface modification of CNT. Application of polycarbonate. Used in automotive industry because of their ability to reduce weight and fuel consumption, providing impact resistant and good optical properties. Used in electrical insulation because of the high electrical resistance of their surface. Used in aeronautics and telecommunication because of high impact resistance and toughness, large plastic deformation before failure, and good thermal stability. Lastly, conclusion. The polycarbonate materials are self-extinguishing. This is also an essential quality, especially in areas which are prone to fire outbreak. From this electrical and thermal of polycarbonate, it is evident why polycarbonates are in high demand for both industry and domestic application. That's all. Thank you.
Hello everyone, my name is Siti Nafarahim binti Muhammad Raslan. Okay, today I'm going to present my subtopic, which is electrical and thermal properties of ceramic. Okay, for electrical properties, okay, we can see that the result of a volume fraction affect the electrical properties of ceramic. For example, the zirconia, bromide, silicon carbonate ceramic. Okay, it was found that the electrical resistivity of value increase as the value fraction of silicon carbonate increase at a certain temperature. Okay, electrical resistivity increase linearly as the increasing temperature of zirconia, bromide, silicon carbonate. the volume fraction of silicon carbonate increase, it means that the volume fraction of electrical insulator increase. Thus, the total electrical resistivity of zirconia bromide silicon carbonate also increase. Okay. Another factor that affect the electrical properties is the addition of a small amount of wood powder. Okay, from the graph you can see the graph shows that the fundamental electrical behaviors of the sample, the electrical conductivity and volume resistivity of the sample, and that obtained from different contents of wood powder. Okay. From the graph, the addition of small amount of wood powder very efficiently increase the electrical conductivity of the ceramic. Okay. The volume resistivity of the sample decrease suddenly with the increasing content of the wood powder, thus indicate an obvious enhancement in conductivity. Okay, for thermal properties, the silicon carbonate content affect the thermal properties of zirconia bromide silicon carbonate ceramic. Okay, zirconia bromide silicon carbonate, also known as the SBC. Okay, from the graph we can see that the SBC20 is shows the higher thermal conductivity and diffusivity compared to the SBC10. But the difference decrease with the increasing temperature. Okay, the graph also shows that the thermal conductivity of the SPC10 is less than the SPC30 at temperature less than 900 Celsius. Okay, therefore, another reason for higher thermal conductivity of the SBC20 and the SBC30 composite at lower temperature can be the higher silicon carbonate volume fraction compared to the SBC10. Okay, it may be therefore inferred that the composite with higher silicon carbonate content tends to show sharper decrease in thermal conductivity with the increasing temperature.